Hi there, I'm Nick Gangemi. This talk is entitled Knock Knock, Who's There? Fresco. Detection of Delaminations in Fresco Paintings Using Tap Tests. So right away, I want to acknowledge our great team that we have. We have faculty from 3 universities, but the core group is this group of students from the Catholic University of America in Washington, D.C. And this group has been using laser vibrometry to assess the conservation status of frescoes in the U.S. Capitol building. These fresco paintings are all over the walls and ceilings, and they consist of multiple layers of plaster that are applied to a brick backing structure, and the artwork would be done on the outermost layer. So really what we're after is finding these delaminations, which are areas of the plaster that have either become separate from themselves, as in this case, or the plaster has actually become separated from the underlying brick, as is the case right here. So the objective of these investigations is to locate and identify the shapes of these defects so that the appropriate preservation measures can be taken. This time around, we investigated a frugal approach that is in the spirit of this session. So the traditional methodology would be to knock on the fresco and listen to the sound of it, but that's a little bit subjective. So what we really wanted to do this time around was apply some techniques and see if we can give that knocking on the fresco technique a little bit more of a scientific justification. So to do this, we had to make surrogates of the frescoes because we didn't want to be knocking on the real artwork. You know, we're not professionals at this sort of technique, so while we learned it, we had to come up with these defects. So what we do is we embed a ginkgo leaf shaped layer of air. So this is the shape of our defect that we are looking for. And we embed it on a brick backing structure, and we apply 2 layers of accurate plaster. Another advantage of this is that we know the shape of the defect, whereas on the real artwork we might not necessarily know the shape. So this allows us to test if we're actually resolving the shape of the defect correctly. So our experiment is actually very simple. We use a little hammer to tap on the fresco surrogate in a grid pattern, and we simply record the radiated sound from the tap, and we can then analyze it and determine if there are relevant features that can be isolated and then we can do something meaningful with them. So here's a great example. This is 2 taps compared to one another. The blue is when you're not on the defect, and the orange is when you are on the defect. And in this case, we can see that we have a resonance from between 200 to 500 hertz, and that there's actually a very big difference between plaster that does not have a delamination and plaster that does. So we exploit this. We can then take our grid of points that we tapped on, and we can reconstruct them back into a grid, and we can look at different frequency bands. And so here's an example. The brighter colored areas indicate the plaster is resonating more. And so this shows you that there is in fact a delamination in the center of our fresco surrogate. But from this and from this plot on the left, we can tell that we can maybe get a better result by looking at more frequency bands. And so that's what this plot is. I've overlaid the shape of the ginkgo leaf defect onto these plots. And as we move up in 3rd octave bands, we can see as we get to higher frequencies, we are actually able to bring the shape of the defect into focus. Now, there is a drawback. As you get higher, it does become quite noisy, and you start to get, sort of a nonsensical result. But right in this area, these frequency ranges, it becomes very viable to actually use these tap tests to find these defects and accurately resolve the shape. So right here, this was kind of our best case scenario. We've proven that these tap tests are viable and that different resolutions can give us different benefits. So far, we're happy with this shape resolution. We're happy with our ability to simulate these frescoes using our surrogate. And in the future, we hope to refine these processes further. So thank you very much for listening, and that is my time.
Awesome. Thank you so much, Nick. That was really cool. Thanks for sharing that with us. And We're going to go ahead and field questions for your session now, so you can turn your camera on and unmute if you're Nick. And then I'm going to pull up the questions. All right. So to get us started, we have a question from Hannah Daniel. Could your research be used in other types of conservation efforts beyond frescoes?
I suppose it could. It depends upon the sort of nature of the defect you're looking for. If there's an acoustic nature to it, I suppose we could use it. The reason it works so well on frescoes is because of the nature of how a fresco is actually made. You have these layers of plaster, and because they become separated, it kind of, in a way, it acts like a drum head. So because there's this gap of air, it is allowed to move. And that's why this technique works particularly well on frescoes. But anything with an acoustic signature could be used.
Oh, good to know. Thank you for answering that. Uh,
Sure.
this is a follow-up from Hannah. What inspired your choice of research topic?
So I admit that I am the newest member of this team, but our group at Catholic University has been doing this since like 2003. What inspired it is we have a lot of expertise with this technique called laser vibrometry. And so that's kind of what started this whole thing of looking at these fresco paintings. And there was a group in Italy that we interact with that was also doing this. But in terms of my specific research, I have a background in air acoustics and physical acoustics, and also a lot of research related to musical instruments where we're analyzing signatures of resonating bodies or features or anything like that. And so when I was talking to Joseph Vignola, who's the director of the program, we were thinking that traditionally they use this methodology where you knock on it and listen. And there must be something that the trained conservator is listening for. And nobody ever really went down the path of seeing if there was or giving a more scientific description of what these people might actually be listening for. Because they just go up there and tap on it. And their years of experience, they can draw lots of conclusions. But we really wanted to put their experience knowledge into an inexperienced person's hands.
Oh, how interesting. Thank you for that detail. Our next question is from Molly, and she says, "Great talk. How long does it take for a full tap test?"
So our sort of highest resolution that we did is 19 by 19 points. The way we do it is we record continuously and then we can isolate the peaks. Typically, the advantage of that is you don't have to be incredibly precise with your timing because the computer program can find each peak. We typically do about a second between each strike, so it takes about 6 minutes. You probably could go faster, but to cover a 19 by 19 grid at 1 inch spacing, it takes about 6 minutes.
Oh, good to know. Our final question is from Avery Thompson. Oh, wait, we have a couple more actually, but our next question is, are you planning to use this method on real life frescoes? I know you mentioned the ones in the Capitol. So do you have any specific ones in mind?
I don't think we are planning on using this technique on real life frescoes. The reason is that we essentially have to strike the fresco. So that's why we used this surrogate approach, because the surrogate serves two purposes. We can put the defect of the exact shape that we want to know, and then also we don't have to worry about possibly destroying a very precious work of art. So when we go to the Capitol, the image that's on the screen now, we measure the frescoes at the Capitol with the laser vibrometer. It's completely non-contact. Were
And
there
then
two questions there?
does that mean that you have plans to make this equipment available for conservators to use? And if so, is there a timeline? And do you have a timeline for that?
We don't have a timeline for that. We don't have immediate plans. Really, we're not really developing equipment. We're just analyzing a traditional technique.
You're doing some research. That makes sense. Thank you so much. That was our last question. That last one was from Avery as well. Thank you all for your questions.
Thank you.
I'm gonna, um, journalists who'd like to see the embargoed press release for this session can check out the link I'm putting into the chat right now. So this is embargoed until the session time, which you can see on the screen here, which is Thursday, November 21st at 11:25 a.m. And if you'd like to see the press release about it and your media, you can check out this link from Newswise.